I'm going to lay out for you a scenario, and then we're going to go through a series of steps, a series of questions that I'm going to ask, and we're going to be utilizing StatCrunch to help us get answers to these questions. Suppose the proportion of registered voters who are declared Republicans in a certain congressional district is 0.42. In some states, including the state of Illinois, the state legislature has the responsibility to redistrict congressional districts. After redistricting United States congressional districts in Illinois, members of the Republican National Committee wonder if the proportion of Republicans in this district is now less than 0.42. In other words, the redistricting wasn't favorable to Republicans for that particular district. To determine that, the RNC sampled 300 registered voters in the district and found 120 are registered Republicans. The RNC would like to know if this represents evidence the proportion of Republicans in the district is less than 0.42. First, what's the null and alternative hypothesis that the RNC is trying to test here? What is the parameter being tested here? A proportion. What's the statement of no change, no effect, no difference? If nothing's changed within this district, what would we expect the proportion to still be? Yeah, 0.42, right? So our null hypothesis is that the proportion is still 0.42. Again, that's the statement of no change, meaning no change in the proportion of registered Republicans before and after the redistricting. And what is the RNC looking to gather evidence to show? Less than, that the proportion declined. So our null is, again, the statement of no change, no effect, is that the proportion is 0.42. The alternative, the statement we're trying to gather evidence to demonstrate, is that the proportion is less than 0.42. So the question is, does getting 120 out of 300 registered voters who say they're Republicans demonstrate evidence that the proportion has gone down? I mean, let's think about this. If we got a sample proportion of 120 out of 300, what does that work out to? 120 out of 300. I'm sorry? It's 0.4? 0.4. And so 0.4 is certainly less than 0.42, but is it significantly less than 0.42? What do I mean by significantly less? Is it possible to get a sample proportion of 0.4 from a population that's assumed to be 0.42? Remember, we always assume the statement in the null is true until we have evidence to the contrary. Put another way, how likely is it to get a sample proportion of 0.4 or even less than that from a population whose proportion is assumed to be 0.42? To answer that question, what we can do is simulate this survey over and over and over again. So I'm going to go to StatCrunch, and I'm going to use the statistical applets. Applet, simulation, and I'm going to do the coin flipping applet. What's neat about this applet is I can make the probability of heads anything I want it to be, and I'm going to make the probability of heads 0.42. Meaning, I'm going to flip a coin. If it comes up heads, that's a person that's a Republican. If it comes up tails, that's a person that's not a Republican. And I'm going to do this 300 times. So notice, I'm assuming the proportion of Republicans is 0.42 because I'm noting that the probability of heads is 0.42. And I'm going to flip 300 coins. Ultimately, I want to know how often I get 120 or fewer. Meaning, how likely is it to get 120 Republicans out of 300? Because that's what I observed, under the assumption that the likelihood of getting a Republican is 0.42. So I'm going to do this one run so you can see how the applet works. I click one run, and you can see I got 123 heads. You see that? Out of the 300. Meaning, essentially what I had the applet do is go out there, survey 300 folks in this district, and ask them, are you Republican or not? 123 came back and said, yes, I'm a Republican. Let me do that one more time so you can see. This time I went out and surveyed 300 individuals in this district, and my survey result came back with 126 saying, yes, I'm a Republican. I'm going to do this over and over and over again and see how often I get 120 or fewer that say, yes, I'm a Republican, when the proportion that is Republican is assumed to be 0.42. And you can see here the proportion of times that occurred was 0.278. 0.278. So, how likely is it to get 120 or fewer who say they're Republicans when the population proportion is assumed to be 0.42? The likelihood is 0.2784, meaning if I conducted this study 1,000 different times and the population proportion is 0.42, I would expect to get this type of a result about 278 times. Bottom line, it's not that unusual to get a sample proportion of 0.4 or less from a population whose proportion is assumed to be 0.42. All right, now let's change the scenario. Now suppose a random sample of 300 registered voters in the district results in 114 that are registered voters, or registered Republicans. 114, not 120. So now my p-hat is 114 out of 300. What does that work out to? This is 0.38 on the nose. Does this represent evidence that the proportion of registered voters in the district is less than 0.42? I mean, 0.38 is certainly less than 0.42, but is it significantly less than 0.42? In other words, how likely would it be to get 114 or fewer registered Republicans in the district if the proportion of registered Republicans is still 0.42? So now we just go back to our applet, and I'm just going to reset it so that we start all over again. But now I want to know how likely is it that I get less than 100 or fewer than or at least equal to 114. Right? So I do this 1,000 times, meaning I went out and surveyed 300 registered voters in this district 1,000 different times. Out of those 1,000 times, 77 of the time I saw 114 or fewer that are registered Republicans. So the 0.077 basically represents the likelihood of observing 114 or fewer Republicans in the district if the proportion of registered Republicans is still 0.42. So it's less likely than it is of getting 120, because I'm quote unquote further away from what I would expect, from what I'm assuming about the population. So again, according to this applet, the likelihood of obtaining 114 or fewer Republicans out of 300 from a population whose proportion is assumed to be 0.42 is 0.077. One last scenario here. Now, suppose in a random sample of 300 registered voters in the district, we have 105 say they're registered Republicans. What's the sample proportion here? 105 successes out of 300 is what is the sample proportion? On the nose? Does this represent evidence to convince you that the proportion of registered Republicans has gone below 0.42? To answer that question, once again, what we can do is go to this applet, and we can say how likely is it, get 105 or fewer that say they are registered Republicans. Under the assumption the proportion that is registered Republicans is 0.42. I do the simulation, and you can see in red down here, I only observe 105 or fewer that are registered Republicans if the population proportion is 0.42, is what? 6 times it only occurred. So if the population proportion of registered Republicans is 0.42, we would see this type of a result, 105 or fewer, saying they are, in only 6 out of 1,000 trials of this study. So 105 is highly unusual type of result to get if the statement in the null is true. So here we're observing something that is highly unusual if the statement in the null is true. Notice, as my sample proportion moved further and further away from the assumed value of the population proportion, the observed results become less and less likely. See that? So as I go from 0.4 to 0.38 to 0.335, the results become less and less likely if the statement in the null is true. So in this last scenario, where you have results that are highly unusual if the statement in the null is true, you can come to one of two conclusions. So in this last scenario, we observed results that are highly unusual if the statement that P equals 0.42 is true. That means we can come to one of two conclusions. Conclusion 1, the statement in the null is true, and we just happened to survey a lot of non-Republicans. Or we were just unlucky and didn't grab a bunch of Republicans in our survey, right? But nothing's really changed. Statement 2, or conclusion 2, the statement in the null is not true, and the population proportion of Republicans is less than 0.42, and this explains the lower proportion in our sample that are Republicans. We prefer to accept the second statement as the better explanation as to why we got these results. It's not to say that statement 1 couldn't be the explanation, because it could happen that you get only 105 Republicans out of 300. We can see it happened, even though the population proportion is 0.42. So it could happen, it's just not likely to happen. Now, these proportions here, the 0.06, the 0.077, and the 0.2784, in general, we refer to these as p-values. They're called p-values. A p-value is a probability that measures the likelihood of obtaining a sample statistic as extreme or more extreme than the one obtained under the assumption the statement in the null hypothesis is true. Right? So here the p-value is 0.006. The likelihood of obtaining a sample proportion of 0.35 or less from a population whose proportion is assumed to be 0.42 is 0.006, meaning we observed these type of results, 0.35 or fewer, in 6 out of 1,000 trials of this study, repetitions of this study. So clearly 0.35 is an unusual result and likely represents evidence against the statement in the null that the proportion is 0.42. Here we have some evidence against the statement in the null, right? Because we observe something that happens about 7 or 8 times out of 100 if the statement in the null is true. Here, getting a sample proportion of 0.4 from a population whose proportion is assumed to be 0.42 is not at all unusual. Now, in all 3 of these simulations, you should take note of the shape of the distribution of possible outcomes. What's its shape? Pretty bell-shaped. And notice that in each of these situations, the center marked in green is around what's 0.42 times 300? 126. See how each time it's centered around what you would expect if the statement in the null is true at 126? So this type of outcome might suggest to us that we could use a normal model to do this analysis instead of this simulation. I mean, the simulation is going to work every time, and you could always do it, right? But the normal model, based on these outcomes, it suggests that that might work as a way to do this analysis and obtain p-values as well. So check this out. We want to verify the normal model may be used to describe the sampling distribution of the sample proportion for each situation in parts B through D. Remember, we can use the normal model provided n times p times 1 minus p is at least 10. Here, n is 300, my sample size. The p that we use here is the proportion stated in the null hypothesis. Why? Because we assume the statement in the null is true until we have evidence to the contrary. So we assume the population proportion is still 0.42. So we do 300 times 0.42 times 0.58, which is 1 minus 0.42. I get 73.08, which is certainly at least 10. I also want to verify for my independence requirement that the sample size is no more than 5% of the population size, provided there's at least 6,000 folks in this district. We're good to go on that as well, and odds are there are going to be at least 6,000 folks in a congressional district, right? And so I think that the independence assumption is pretty clear-cut. And so this tells us that the distribution of p hat is approximately normal. The mean of p hat is going to be equal to the proportion stated in the null, which is 0.42. Why? Because again, we assume the statement in the null is true until we have evidence to the contrary. The standard deviation of p hat is going to be the square root of P 1 minus P over my sample size N, I'm getting that is approximately 0.0285. And so visually what we're saying here is these are the possible values of P hat. There's my normal model with the mean at 0.42. And what we're going to do now is use this model to compute how likely it is to get a sample proportion of 0.4 or less, or how likely it is to get a sample proportion of 0.38 or less, so on and so forth. Use the normal model to determine the probability of observing 120 or fewer Republicans in a district whose population proportion is 0.42. 120 is a p hat of what again? Is that the 0.4? Okay, so what we're doing here is we're basically saying there's your distribution of p hat. There's your normal model. There's a mean of 0.42. 0.4 is right around there. It's probably even closer than that. And so we have to find this area. This is basically the probability of getting a p hat less than or equal to 0.4. So we're going to go to StatCrunch, Stat Calculators, Normal. The mean is 0.42. The standard deviation was 0.02, what was it again? 85. And we want the probability of getting a sample proportion less than 0.4. See that? Click compute. So I'm having the probability that p hat is no more than 0.4 is 0.2414. If we compare that to what we got in our simulation, it's 0.2784. They're close, but different, right? But pretty close. Either way, here we're saying we'd get these types of results about 28 times out of 100. And down here, using the model, we're saying we're going to get these kind of results about 24 times out of 100. In either case, the result is not all that unlikely under the assumption the statement in the null is true. Letter G is asking to use the normal model to determine the likelihood of getting 105 or fewer Republicans. So remember, 105, that's a p hat of what was it, 0.35? Is that the one? And so if I go back to StatCrunch and all I got to do is change this to 0.35, click compute, and I get 0.007. You see that? 0.007. If you look back at our simulation, it was 0.006. So in our simulation, we observed results of 105 or fewer in about 6 out of 1,000 repetitions of this study. Using our model, we observed a sample proportion of 0.35 or lower in about 7 out of 1,000 repetitions of this study, assuming you treat that area as determining the likelihood of getting these types of results under the assumption the null is true, which is what we're doing because our population proportion is 0.42. So the bottom line is this. All we're doing when we use this normal model is making a judgment about how likely it is to get the types of results that were actually observed under the assumption the statement in the null is true. Whether you use the normal model or simulation, the results are going to be consistent. The difference is that the simulation actually does go out and pretend, at least, to survey the 300 individuals over and over and over again and see how often you get those types of results. Whereas the normal curve just jumps right to the chase and says, I'm going to use this as a proxy for a measure of the likelihood of getting those types of results without actually going out and conducting the survey. Why can I do that? Because I know from statistical theory that the outcomes are going to follow that basic shape. That's what makes this model so powerful. We know, based on statistical theory, that that curve pretty accurately describes what will happen if we did this over and over and over again. And that's what makes that curve so powerful as a tool in this class. Now, ultimately, we're not even going to need to go through this process because StatCrunch is friendly enough in that it will allow you to do this type of hypothesis testing directly. To do this in StatCrunch, all you need to do is go to Stat, Proportion Stats, One Sample, and we happen to have summarized results. Let's say we wanted to do the one where we observed 105 successes out of 300 trials. So you had 105 successes finding a Republican out of 300 trials. You want to know, is this evidence to suggest that the proportion of registered Republicans is now less than 0.42? You click compute, and there's the 0.007 that we got from the normal model, called the p-value. Z-stat is your test statistic. So this p-value of 0.007 is saying if the true population proportion of registered Republicans is 0.42, the likelihood of observing 105 or fewer out of 300 who say, yeah, I'm a Republican, is only 0.07007. Meaning, if the statement in the null that the proportion is 0.42 is true, you would see these types of results, 105 out of 300, in only about 7 out of every 1,000 times you did this study, which is highly unusual. So you would take that low p-value as evidence against the statement in the null. In other words, you would reject the statement in the null and say, you know what, my sample evidence suggests the proportion is now less than 0.42.